Chances are you've heard the classic idiom, cats always land on their feet. And while this does seem to be true, is it backed up by science? Why is it that cats have the impeccable ability to survive falls from such ridiculous heights? Through the process of evolution, cats have developed an unparalleled talent at falling from large distances without sustaining injury. By controlling their moment of inertia, angular momentum, they create what is called a non-lethal terminal velocity, meaning that they are actually more likely to survive while moving at terminal velocity. This is what allows them to survive falls from up to 32 stories high.
Naturally, we decided to test this ourselves. We had a selection of 5 cats, each with 9 lives if anything goes wrong. That makes for at least 45 trials. We weighed the cats and numbered them accordingly, and got the necessary measurements of their height and width. We then scouted a location for the drop, and waited for a day with clear skies and no wind.
With our initial experiment having gone awry, we realized we need to educate ourselves further and find out exactly what allows this phenomena to happen. It largely has to do with the moment of inertia of the cat as it falls. However, you first have to understand rotational motion, or an object's angular velocity. Rotational motion is similar to linear motion, or motion in a straight line. However, the constants are slightly different. For example, the kinetic energy of linear motion is equal to the mass times the velocity squared, but when calculating rotational kinetic energy, instead of the mass of an object, we use what is known as the moment of inertia, which is then multiplied by the angular speed squared.
The moment of inertia of any given object is determined by the distance the mass is distributed from the rotational axis, or I equals mr squared. An application of this can be seen when sitting in a swivel chair, tucking your arms in to speed up or stretching them out to slow down. Applying this to cats, they tuck in or stretch out their tail and legs to adjust their moment of inertia, allowing them to speed up and slow down slightly while falling. This gives them more control of their rotational motion, and which part of their body will come in first contact with the ground.
Since increasing moment of inertia acts to maintain the cat's position in freefall, it needs to utilize angular momentum to manipulate its body into a feet-first position. While falling, the cat's center of mass allows a standard parabolic path and theoretically its angular momentum to remain constant. The cat then uses the lack of outside torque to manipulate its angular velocity, rotational inertia, and positioning. This is also made possible by the physical composition of its spine, having far more vertebrae than humans, allowing it to twist farther and with more ease.
It's these traits that give cats their aptly named non-lethal terminal velocity. Once a cat has reached its maximum speed of freefall, they find themselves with more than enough time to properly position their bodies for an optimal landing, meaning that in a study of 132 cats, only one of the 22 cats dropped from above 7 stories died. This is because at higher heights they have a far longer opportunity to optimally position themselves. All these factors can easily be seen when footage is slowed down. We dropped some of our own cats in a safe environment to demonstrate this. As you can see, their bodies remain remarkably steady while descending before landing safely on their feet.